Это не я, это Тоэн. Ну, в смысле? Ну, это не я, это Тоэн, ну, в смысле.
Ну, какой-то такая.
Okay, I just... So what was the notation for what I... Where's Sam?
Hi.
Where are you? Wait a second. Oh, sorry. What I did not ban T-rat. What?
W of GB.
W of GB. But like geometrically, how do you call it? Well, like you impose this equivariance condition. What? How do you say it? How did we denote it?
I wrote it D of G of A mod G of L mod B of K.
Okay, so. Okay, so we have this d mod.
So I'm just repeating what Sam said?
Yeah, yeah. Roma wanted it. Okay, so, and then kind of we impose this equivariance with respect to the adelic end, whatever that means. Yeah. So then. Okay, so the message is that it's supposed to be equivalent to quasi-coherent sheaves on Lox's B check equipped, well, with connection along
Connection along means just vertical.
yeah. Okay, so okay, so the question was, why is it natural to kind of, why is it the natural thing to do? Yeah? So that was Roma's question. So here is, I mean, here's one possible interpretation of this. So,
Just one second. Is it, I mean, eventually, will there be a local analog of this statement?
yeah, so this is proved.
That one will be more natural than the global one.
Well, you'll see in a sec. So, I mean, unfortunately, we didn't let Nick get to his thing yesterday, so he would have known it. So had he gotten to what he was planning to do. So, okay, so maybe what I'll say will be less clear without this local thing, but let me give some interpretation of this category, which, okay, so after the local thing will be said, here is how you may think of this category. Consider the following datum. Stack of, okay, local systems, okay, let me just say it without writing, local systems with respect to G check equipped with a rational reduction to B check.
As a local system.
As a local system. Well, you can imagine that kind of at the level of physical points, rational reduction is the same as a global reduction. But so it has, and you can also imagine it has a non-trivial DG structure, and it will be this. In the same vein as the following. So I'll go back to kind of closer to Nick's talk, and then that's how derived stackable will appear. So if you consider, let me just say it in words. Okay, that's basically kind of Nick's message from yesterday, which will be reiterated this afternoon. So forget B. Local systems with respect to G check, which are only defined rationally, we should think of them as D modules quasi-co on log sys, let me call it G check generic. So we consider local systems which are only defined generically. But formal neighborhood of actual local systems. I don't want the local system to have singularities, but kind of formal neighborhood of genuine local systems inside local systems defined generically. So these should be thought of as D modules on log sys G check. This is Nick's thing. So Nick.
That follows from derived Satake.
This is derived Satake. Well. No, derived Satake. So this is derived Satake plus Nick. No, see, sorry, there's no derived Satake because there's no Langlands duality here. So there is no Langlands duality, so forget derived Satake. So you should think of this category as follows. So you have the stack of local systems, and you are quotienting it out by the Hecke stack. So that's what it is. And what Nick tells us that if you're quotienting out by the round version of the Hecke stack. That's what's going on here. And what Nick says is that if you take some kind of modular problem of section, okay, in this particular case, if you take a stack of local systems and impose equivariance on the quasi-coherent sheaves with respect to the round version of the Hecke stack, you'll get D-modules. And the same thing here, but in a relative situation. So again, no derived Satake because no G versus G check, but that's, so this is Nick.
But in what sense does it clarify?
In what sense did I clarify anything?
Why we should think of this as more natural than the previous?
Because see, it's on the level of notation it matches better because these are G bundles which are reduction to be defined generically. This is quasi-coherent log systems with.
It's fine, but Kevin says, I mean, why do you oppose telling the local answer now? Probably take it.
No, I'm not opposing it. Just so Sam will do it. It's part of his talk.
But can I just do it right now?
Yes, now.
Okay.
I need the mic.
Oh. Thank you.
Well, okay, so just to continue with what Dennis was saying, so, how would a person prove this? And
You promised local answer.
from,
No.
what was that?
You promised to give the answer for the local category right now.
Right. So first of all, what is the local category? Braverman.
Is it a question to me? No, what is local category?
Uh-huh.
Local category is just category of D models on G of K mod G of O equivariant and N of K.
Great.
Yes, yes.
Oh yeah, yeah. So we have the spongy B ret. We're supposed to impose this adelic equivariance. So Dario has taught us that there's a fully faithful functor to the Ron version of Gur-G. Let me just ignore Ron. Okay. Keep it. Well, that could get us into trouble. So I'm supposed to embed this category into here. And then if you just trace through what this adelic equivariance meant, that was the same thing as saying that I mapped into the N of K Ron version of the category. So now this is supposed to be equivalent to something complicated. And I have to tell you what that embeds into on the local side. Answer. So, oh, I'm running out of space. OK, it's ind co. Of local systems for G-check on the disk, which are given, similarly, a rational reduction to B-check. So rational for the disk should mean on the punctured disk.
Okay, so can you now explain what this really means over reporting?
So
Can you write as the modules of a certain algebra?
great question. Basically.
And this is the next step, but can you do this exercise?
Yeah. So over a point, this follows from the theorem of U, and
Just give the answer.
so it follows from a theorem of Arkhipov, Bezirkovnikov, and Ginzburg. And what the theorem says is that D modules on GER G that are equivariant with respect to the unipotent radical of Iwahori. So Iwahori hasn't appeared, so G of O maps to G. Iwahori, by definition, is the inverse image of the Borel, and unipotent radical of Iwahori is the inverse image of N. So they say that this category is equivalent to coherent sheaves on what's called the derived Springer fiber. So I just won't write it. So, well, here's what it says. For symmetry, point mod G check over G check mod G check of B check mod B check. They proved this theorem, and a fact is that, like a very general fact here is that this category is equivalent to my N of K equivariant category.
Explain why the right-hand side is the same as that right-hand side.
As this right-hand side?
Yes.
Yeah, so you should read, so this is literally local systems on the disk, this point mod G. And
I mean, this G-check mod G-check, this is the local systems on the puncture disk in a sense, but somehow, but I'm trying to say, what is the structure that is written there? Is it reduction to?
B check on the puncture disk.
Just reduction to B check on the puncture.
So
can you also say it as some kind of connection in some direction?
No, that's exactly Nick. So Nick says that. So what Nick says that identifying two things over the puncture disk, if you integrate over the run, for global sections will give you the connection.
Yeah.
So that's Nick's thing.
So here, direct connections are just irrelevant.
Again, let me just reiterate Nick's things.
What was the question?
So he says what
there
is
you
the
are.
connection. So here we have a
side, on which side?
locally, you don't see any connection, no theorem, but you only see the puncture disk. So let me just say, okay, let's just say Nick's thing more generally. So Nick says this, that you are solving a problem, so you have some D stack over X, and you're trying to classify horizontal sections. Okay, that's a global object. So now you want to describe the infinitesimal group order. So you want to say, what does it take for a quasi-coherent sheet to be a D module?
On this thing.
On this thing. So here's what Nick says. So you need to impose equivariance with respect to the round version of the following thing. Take endpoints on the curve. And so here's your group order. These are sections on the entire X. Now you report that just a pair of sections on X identified away from these several functions.
Horizontal?
Yeah, everything is horizontal. Sections, doing this identification away from functions and integrating over the run will produce for you the infinitesimal group order. This is what he says. So that's why the appearance of this puncture disk at the end translates into connections. Here we're doing some relative version.
And so why is thinking about this in terms of connections, why is it kind of helpful to you? Why is it better for you than just saying you have generic reduction? Is it just a linguistic thing, or is it really needed?
Well, for example, I don't know how to describe the category of things equivariant with respect to some groupoid. This is a very particular, there's a very concrete algebra. It's much more computable, this thing.
So the fact that you hold X
yeah.
should be at some level bigger. In particular, is it related to the fact that in this part product we have the focus on the function some generators do information space.
Okay, no, I'm not getting this. Explain that.
So
No. I want to understand this. Maybe in the break. I want to understand what you're saying.
But then you can answer.
No. What was the first question?
The first question. So there is some fact that people mix.
Yeah.
Think just precise. Can you comment on why this happens?
there's a map in one direction, very obvious, because if those 2 points are infinitesimally close, and the fact that it does the entire thing, I don't know. Again, it's one of those local to global principles. We didn't let him finish, so yesterday he only did quasi-co-global sections. So it's some kind of local to global principle, which you can't do that. One of those facts in life. That's one of the reasons chiral algebras are useful.
No, but it's not just local.
So going from local to global and also from knowledge to shape.
Okay, but no, it's. But I really want to know what did you say about it? No. But can you say it again? Related to what directions? Maybe it did. Okay, whatever.
So just about this Nix thing. So you said, I mean, you somewhat didn't formulate it precisely. As I said, that if you impose equivariance under this groupoid, this is the same as you have a connection.
It's same like connection.
Just a connection on this thing. So
yeah.
Not over something, but
well, this was the absolute version, but you can also do the relative version, and then you arrive exactly to this. You can do this Z1 over Z2. What should we do? Declare. So the next
Are there
topic.
any questions?
Well, I have a question just really to unravel this for Q1, but you said that no one will do it in the blackboard.
I'll do it.
Q&A is 5 more minutes.
So when is next up? When is the schedule?
So according to schedule, there's Q&A for 5 more minutes, 15-minute break, and then it's like.
Okay, so it's not so bad.
So when you can do this Q1?
No, I'll do this. I have to do this. I'll do the calculation and I'll show you. But everybody's asked the woman again. Can you say it again?
So again, in the local situation, we are the local category is a pair of local systems.
On the disk, identify the way from the function.
Disk, and this is a purely teacher scheme.
Yes.
So the tangent space lies in logical degree.
Tangent space logical degree plus 1.
Plus 1, and in the global case, well, there are actual tangent vectors in logical degree 0. And somehow equivariance with respect to this groupoid, which is pure DG groupoid. Local nature and acid and variance.
Yeah, I mean.
Certain groupoid at the global level.
So you're wondering why?
Yeah.
So that is, I think that's just H1 in the curve.
Okay. So on the left side of the table, there is a linear group on the right side.
There should be brown on the right side.
Regarded as factorization category. So erase this and these factorization categories, in particular, as exceptions of round. Yes.
So the energy adels that appears there, is that the round space thing, or is it?
Yeah.
What does it mean? It's like an action of the.
So you have this factorization scheme responding, and you have this factorization group scheme acting.
It's just notation.
Yeah.
In terms of saying what's there and what's not there, right? So one thing that this theory makes to discuss is why it says integral as opposed to
It's because in this theorem, it's co and not perf.
So my take is
in
that
the end we want to get quasi-coherent. So there is something to be checked, but actually you don't need this.
no. So you see what is happening here. You're going forward. No, but I think that sounds way too technical.
Wait, well,
I wanted to make a point that there is.
So you have to be really careful about in-co versus quasi-co.
no, but you can address that here. So we have some local.
It is in your notes.
That could be. So. So we had some particular global spectral category. It was by definition a full subcategory of some int-co. So it embeds into this int-co. You embed that int-co into the local gadget. And then the point is, like, you have to check that the essential images match up under this local equivalence. And there you do, because both things are generated by things coming from Fourier Mukai in the usual sense. So that's what happens. But